In this session, we will look at some examples. But before that, let us talk a little bit about an algorithm for link frame assignment. So we already discussed in the last session the Dannewitt-Hartenberg notation and a systematic procedure for assigning frames. There is little bit more to that procedure, and in this algorithm is there to help us. Because sometimes there can be a confusion in frame assignment, so it gives us some steps. So let us look at these steps briefly. I'm just going to read the algorithm and illustrate it with the help of some examples. So link 0 and n, link 0 is the first link and link n is the last one, that is the end effector. Those are connected to only one link. Okay, so how to assign frames for that? Because all the intermediate links are connected to two links, so you have two axes corresponding to them. For link I, you will have an axis I minus 1 and axis I. But for the last link or the first link, that is not the situation. So those are handled separately. Okay, so link 0 and n are assigned frames after the intermediate links, which are links from 1 to n minus 1. So first we assign frames for link 1 to n minus 1, and after that we do for link 0, that is the base frame, and link n, that is the end effector. The procedure is label links 0 to n, link 0, link 1, link 2, and label joints from 1 onwards, and label axis also. Axis labeling is starting from 0. Okay, we already discussed that. And then we align zi with axis I. Okay, that is straightforward, we discussed that also. But after that, when it comes to the assignment of frame xi, then there are different situations. So I'm just going to read the algorithm first. So assigning frames to frame number 1 to n minus 1, those are intermediate frames. There are different scenarios here. Scenario A, if zi minus 1 and zi intersect, okay, if that is the situation, this x here, this cross here, this is a short way of my writing, if they intersect, okay, then origin of frame I will be at the intersection of these two, and xi will be perpendicular to these two. Okay, so there is nothing special about it here actually, because xi is perpendicular to both zi and zi minus 1, and if they intersect, then the perpendicular will start from the point of intersection and just perpendicular to that. Okay, so that is one scenario. Other scenario is if zi minus 1 and zi are coincident. Okay, so that is the same axis is zi and zi minus 1. Okay, then origin. Okay, origin will be on the common axis, that is clear, because xi is common perpendicular to zi and zi minus 1. Okay, so origin will be on common axis. But now there is ambiguity about common perpendicular. You can draw infinite number of common perpendiculars because they are just coincident. So the algorithm says that if joint I is revolute, okay, then what we have to do is origin of I, frame I, is coincided with origin of frame I minus 1, and xi is coincided with xi minus 1. Okay, xi axis is coincided with axis xi minus 1, and this also results in making parameter di 0. Okay, this is a joint parameter, the way it is defined. You saw that previously, that also becomes 0. But if joint I is prismatic, then xi is made parallel to xi minus 1, and this also makes AI 0, and origin, this O is origin of frame I is taken at distal end of link I. Okay, we'll look at some examples. So that is if zi minus 1 and zi are coincident. At this point I'm just reading the statements here. Another scenario is if zi minus 1 and zi are parallel, or they are in parallel planes. Okay, so if again if they are in parallel planes, then also the common normal is not unique. You can have infinite number of common normals. So how to define x is xi? There are two situations. If joint I is revolute, then xi is chosen through origin of frame I minus 1. Okay, and if joint I is prismatic, then origin is taken at distal end of link I, and xi is taken along arbitrary common normal. Okay, so that is the way of assigning xi depending on different situations. If zi and zi minus 1 they intersect, if they are coincident, or if they are parallel. If the situation is none of these, okay, then you are going to have a unique common normal and assignment is straightforward. Okay, so having assigned the intermediate frames, now the step 4 is assignment of frame 0. uh, Assignment of frame 0 is as such arbitrary, but we still keep our convenience into mind, and generally x0, okay, this is corresponding to frame 0, the x is x0, is taken parallel to x1 in home position of the manipulator. X0 is taken parallel to x1 in home position. Okay, x1, see the direction of x1 may keep on changing, but the home position of the manipulator as such it is arbitrary, because manipulator arm is moving here and there, and still we define a position that we call home. Okay, so generally home position is when all the revolute pairs, at all the revolute pairs the joint angle is say 0, and all the prismatic pairs are at their minimum displacement. Okay, all of them are withdrawn inside. Okay, generally that is taken as home position, but that is not necessary. We can define some other position as home position, and from home position arm goes here and there. Okay, so x0 is taken parallel to x1 in home position. So whatever is the position of x1 in home, parallel to that we take x0, then it becomes convenient. So that is for frame 0. And for frame n, which is at the end effector, these are the steps. Origin is taken at tip. Okay, tip means a point on end effector, that is the meaning of tip. Origin is taken at tip. Zn, direction Zn is taken along the direction Zn minus 1. Okay, because there is no axis there, there is no axis n. Axes are labeled from 0 to n minus 1. So there is no axis n through which we can have Zn. Okay, so Zn is taken along Zn minus 1 in approach direction. If joint n is prismatic, then xn is taken parallel to xn minus 1. If joint n is revolute, then xn is taken perpendicular to Zn and Zn minus 1. Okay, so this is an algorithm for assigning frames to links, which is a further elaboration apart from the DH notation. Okay, we are going to look at some examples. These examples are actually solved examples in the book, and this is example 3.1 to 3.3. Let me show you the figure for example 3.1. Let's see. Okay, this is for example 3.1. So what you see here, it is a 2 degree of freedom planar manipulator arm with one rotary and one prismatic joint. Okay, so there are three links here: the base link, link number 1, and link number 2. Okay, link 2 is the end effector. There is a tool point P on this, uh, and there is a revolute pair here and a prismatic pair here. It is a planar manipulator. Okay, very simple. Now, what is the procedure? For now, we have to assign frames to the links, and then we have to also write the DH parameters. And once we have those, we can write the transformation matrix, okay, for our mapping. So the procedure is, first we label the links and axes. Okay, you can see that has been done, I think, in this figure. Okay, or not in this figure. Let us see here. Links are labeled as let us see this only. Links are labeled as link 0, link 1, link 2. Okay, label the links and label the axes. This will be axis 0 and there will be axis 1. Okay, axis 0 and axis 1, and we assign Zi through those axes. So you can see that on this diagram it has been done. This is the first axis. This is Z0. It comes out of the paper. Okay, so I have drawn it in this way, a circle with a dot. That means just like if you have an arrow coming towards you, you are going to see a point. So Z0 axis, that is the joint axis through this joint that comes towards us. And there was a prismatic pair here, so corresponding to that you have axis Z1 that goes in this direction, that because that is the joint axis. Okay, so see, we labeled the links 0, 1, 2. We label the axis 0, 1, and we assign Z0 and Z1 along these joint axes. Okay, that is the first thing. Now after that we have to focus on frame number I to n minus 1, which are intermediate frames. We do assignment for frame 0 and frame n in the end. So here there are only 3 frames, so there is only one intermediate frame, frame 1. Okay, so for frame 1, let us see now what is the situation. Okay, this is our link 1. So to this link we have to assign frame 1, and there are two axes, Z0 and Z1, and they actually intersect. Okay, Z0 and Z1, in this case Z0 is coming towards us, Z1 is in this direction, they intersect. So if they intersect, then what will be the direction of x1? X1 is common perpendicular to these Z, that was written in the algorithm. So common perpendicular to these two, that will be along this. You can see x1. We can make it going it this way or going it the other way, does not matter. Okay, so we got x1. So Z0 and Z1 intersect. It implies use 0.3a from algorithm. Okay, so that has been done here. So we got frame assignment for, we don't have to worry about y1, we don't need that, but we can do that based on right hand rule if we want to do. Okay, now having done that, we have to assign x0 and x2 for frame 0, and actually assignment for the last frame, frame 2. Now for 0, okay, let us again go read the step there, what it says. See, for frame 0, it is arbitrary, but take x0 parallel to x1 in home position. Okay, so let us see. So home position I am taking when this whole thing is at angle 0. That is the home position. Okay, so when this is in home position, x1 is going to point vertically upward. Okay, so we can take x0 pointing vertically upward. Okay, based on that point. So that is x0 is shown here pointing this way. So that is the, and that makes this as the origin of frame 0. We have x0, z0 already. So that is assignment for frame 0. We have used 0.4 from the algorithm, and after that we assign frame 2. For that we use 0.5 for the from the algorithm, and that point is basically the z2 will be along z1. Okay, zn will be along zn minus 1, so we make z2 along z1. That is the first thing. You see, zn is along zn minus 1. Okay, and now the second point is, if joint n is prismatic, here joint n is prismatic, if joint n is prismatic, then we take xn parallel to xn minus 1. So we'll take x2, okay, parallel to x1. So that is what has been done here. So now this completes the assignment of frames. We have frame 0, 1 and 2. Okay, so now after that, based on the this frame assignment, we have to write DH parameters, and we can do that in the form of a table, as you see here. So we write index I. There is nothing for 0 actually. We have to write for 1 and 2. Okay, so link 1 1 and 2, and we have these parameters a alpha d theta. Okay, ai alpha I di theta I, will have to write those values by looking at our frames and thing. And we can also include a column for joint variable corresponding to each joint. What is the variable? For a revolute pair, theta is going to be the variable, and for a prismatic pair, d is going to be the variable. Okay, then there are additional columns here. Based on this, we can write cos theta I. Okay, once we have entry for theta I, we can write cos theta I, sin theta I, cos alpha I, sin alpha I. We can fill those values here, and once it has been done, we'll do how to do this. We'll see. Once this has been done, we can write the transformation matrices 0t1 and 1t2. Okay, 0t1 will be based on this a1 alpha 1 d1 and theta 1, and 0t2 will be based on a2 alpha 2 d2 theta 2, sorry, 1t2, and then 0t2, the overall transformation matrix we get from by multiplying these two. Okay, that's all. Once we have the transformation matrix, then if we have a description of a point in frame in frame 2 on ND factor, and we want a description in base frame, we just multiply that description with this transformation matrix. Okay, that's all what we want. So so let us look at these DH parameters, how we get those. Actually, you'll have to fix the figure. Let me show you that again. Okay, you'll have to fix this figure, how these AI and DI are defined in your mind. Okay, then only you can quickly extract from your frame assignment all these parameters. So this figure has to be clear in your mind. So see, now if we are looking at a1 alpha 1 d1 theta 1, you see frame z0 and z1, z0 and z1 axis, they intersect. So what does that mean? That means link length is 0, so a1 becomes 0. You see, a1 becomes 0. Okay, and what is link twist here? Link twist, you see, will be the angle between z0 and z1. Okay, that is clearly here 90 degree, but you have to measure it in the proper sense. For link 1, you have to measure this angle based on the axis x1. So if you align your thumb along direction x1, then the fingers of your right hand in going from z0 to z1, they curve by amount 90 degree. Okay, that means alpha 1 is 90 degree. That is how alpha is defined. So you see, alpha 1 is 90 degree here. Okay, and now those were the link parameters. Now joint parameters d and theta. Okay, what is theta? theta is angle between x0 and x1, and this keeps on changing. This is a joint variable. It keeps on changing as there is rotation about this revolute pair. So we indicate that by theta 1. Okay, so so this theta 1. And what is d? D is, see, d is this distance along zi minus 1 measured along distance along zi minus 1 measured from, say, this point to this point. So you will see that turns out to be 0 here. So that parameter here is 0. Okay, so similarly you do it for point 2, this a alpha d theta. It requires some time and some practice, but the concept is clear as such. So once you have filled those parameters, you get these matrices and you get this overall transformation matrix. Okay, that's all. We look at another example, example 3.2. Okay, here you have 3 degree of freedom, cylindrical manipulator arm. Okay, 3 degree of freedom, cylindrical. Okay, and what you see in this is there are 4 links here. Base link. Okay, this is one link, another link here, another link here, and there is a revolute pair. There is a revolute pair, and there are 2 prismatic pairs. This can move up and down, this can move in and out. Okay, so like that, the workspace for this arm configuration is a cylinder. We talked about that previously. Okay, so we have to assign the frames for this and work out DH parameters, right? Those transformation matrices. Okay, so all those things. So the procedure is the same. You can label the links starting from link 0, link 1, link 2 and link 3. Okay, then we will assign z axis, because we know the axis of these joints. So see, this is first joint here, this is the direction. Okay, it is a revolute pair here, and this is the joint axis. So through this we'll have z0. Okay, so we label z0. We can take it upward or downward, does not matter. Okay, so z0. Then there is a prismatic pair here between these 2 links, and the direction of sliding is this. So that is the direction of z1. Okay, for this joint axis z1. So we have z1. Okay, so z0 and z1 are pointing in the same direction. There is another prismatic pair here, and z2, the direction of sliding for this pair is along this. So we say z2 is along this. Okay, so we have z0, z1 and z2. So after that we have to assign x-axis for intermediate links. So let us look at link 1. Okay, so for link 1 we have z0 axis going up and z1 axis also going up. Okay, so z0 and z1 are coincident. So how to assign x-axis when z are coincident? We had a point for that. You see, if zi minus 1 and zi are coincident, then what to do? If joint I is revolute, so let us see what is joint I. Okay, in this case joint I, this is joint I. Okay, so joint I here is revolute, so this will apply. If joint I is revolute, then origin of I is coincided with I minus 1, and xi is coincided with x I minus 1. Let us see if that helps us here. You see, we have not assigned xi minus 1 yet, so actually this point doesn't help here as such. we have taken, the way I have taken here is the axis x1 is perpendicular to z0 and z1, and I have taken it like this. It is perpendicular to both, and the way it is drawn, it comes out of the paper. Okay, that is how axis x1 is taken here. Okay, let us look at now how to assign x2. For link 2, we have axis z1 and z2, and they intersect. And when they intersect, then x will be along common normal. There is only one common normal, and we have taken x2 coming out of the paper towards us. Okay, so this is x2. Okay, so x assignment for intermediate frames is done now. And for the last frame, link n, which is link 3 here, we assign z3 along z2. Okay, so z3 is aligned along z2. And then how to assign x3? The procedure is, if joint n is prismatic, then x3 is taken parallel to x2. So we have just done that here. This joint is prismatic, so we take x3 is parallel to x2. So that x3 also comes towards us out of the paper. And in which direction we have x0 for frame 0? x0 and x1 we take in the same direction when the manipulator is in home position. So x0 is also along x1, but see, the direction of x0 does not change, but the direction of x1 will change when this link rotates. Okay, this at the revolute pair there is rotation, so there is a joint variable, an angle theta there. It is not that they are always in the same direction. There is a joint variable. Okay, so we have assigned coordinate frames here, and we write DH parameters. Again, you'll have to refer to that figure, and those parameters have been written. And for each joint, there will be one joint variable. You cannot have two variables. Okay, what that means is, for one, your variable is theta1. Okay, so it varies. But d1 has to be constant. It can be 0 or it can be a fixed number, but it cannot be variable. You can have only one joint variable. Okay, so like that. We have these parameters, and we can write those transformation matrices, and we'll get the overall transformation matrix. Okay, that is this example. You will have to actually do these examples yourself a few times. Okay, then only it will be fixed in your mind. Let us look at example 3.3. So this is an articulated arm. It has 3 revolute pairs, and there is a revolute pair here. Okay, another revolute pair here, another pair here. Okay, so for this configuration, again, we assign links first: link 0, link 1, link 2, and link 3. Then we assign z-axis. Okay, through this one, the z-axis will be along the axis of this joint z0 going this way. Okay, from this one, again revolute pair z1 is coming towards us, and z2 is also coming towards us. So we assigned these z coordinates. And now for intermediate links, we will assign x. So starting from link 1, you see, for link 1, z0 and z1 intersect. So x1 will be along common normal to z0 and z1. That comes out to be this. Okay, or it can be the other way also, does not matter. So we have taken this. So this is x1. Okay, that is done. Now for link 2, we have z1 and z2 parallel to each other. Okay, if z1 and z2 are parallel to each other, then we know common normal will be like this, along this, but there is no unique common normal. So we have a point there. See, if zi minus 1 and zi are parallel, then common normal is not unique. And if I is revolute, then xi is chosen through origin of I minus 1. Okay, xi is chosen through origin of I minus 1. So what we do is, we choose this x2 x2 through origin of frame 1. Okay, that is this point. Through this point we have chosen x2. Otherwise x2, we had see parallel to this x2, we could have multiple choices of x2, but we take this as x2. Okay, so intermediate frames are done now. We have z1 x1, z2 x2. Now we look at the last frame and first frame. For last frame, we assign first we assign z3 as parallel to z2. That is how we do it always. Z2 is coming towards us, we make z3 also come towards us. Okay, and for assignment of x3, we know x3 will be along this perpendicular to z2 and z3, and let us see, there is a point there. If n is revolute, xn is common perpendicular to zn and zn minus 1. Okay, that's all. So common perpendicular to these, and we have taken it passing through this point. Okay, so this is x3. And now we have to also assign x0. X0 is taken parallel to x1 in home position. Okay, we have x1 in this direction. We take x0 also in this direction, x0 also in this direction. But see, another thing we have done is we have taken origin of frame 1 and 0 at the same point. Okay, so although the origin of frame 0 is here, but that frame 0 is assigned to the base. Okay, it can be anywhere physically, but it is assigned to the base, that and base remains fixed, so that means that coordinate frame remain fixed. We have just assigned it here. Okay, we could have assigned it here, then our DH parameters would have been somewhat different. Okay, so we have the frame assignments here, and now you have to write DH parameters in the form of a table, and then you get the overall transformation matrix. Okay, so that is how it is done. So please practice these problems. And this topic I covered from the book Nagrath and Mittal. So there is a book on robotics and control by Nagrath and Mittal. So the contents from that book. We'll stop here.